Urban performance currently depends not only on the city's endowment of hard infrastructure, but also, and increasingly so, on the availability and quality of knowledge communication and social infrastructure. The latter form of capital is decisive for urban competitiveness. It is against this background that the concept of the smart city has been introduced as a strategic device to encompass modern urban production factors in a common framework and to highlight the growing importance of information and communication technologies, social and environmental capital in profiling the competitiveness of cities. The significance of these two assets, social and environmental capital, itself goes a long way to distinguish smart cities from their more technology-laden counterparts, drawing a clear line between them and what goes under the name of either digital or intelligent cities. Smart cities have also been used as a marketing concept by companies and by cities. Definition: a city can be defined as a smart unregistered trademark when investments in human and social capital in traditional and modern communication infrastructure fuel sustainable economic development and a high quality of life, with a wise management of natural resources, through participatory action and engagement to guildos ICTs dormenwas. The smart city concept essentially means efficiency. But efficiency based on the intelligent management and integrated ICTs, and active citizen participation. Then implies a new kind of governance, genuine citizen involvement in public policy. Smart cities can be identified along 6 main axes or dimensions. These 6 axes connect with traditional regional and neoclassical theories of urban growth and development. In particular, the axes are based, respectively, on theories of regional competitiveness, transport and ICT economics, natural resources, human and social capital, quality of life, and participation of citizens in the governance of cities. It insists that smart cities are defined by their innovation and their ability to solve problems and use of ICTs to improve this capacity. The intelligence lies in the ability to solve problems of these communities is linked to technology transfer for when a problem is solved. In this sense, intelligence is an inequality of any territory, any place, city or region where innovation processes are facilitated by information and communication technologies. What varies is the degree of intelligence, depending on the person, the system of cooperation, and digital infrastructure and tools that a community offers its residents. Policy context: the concept of the smart city as the next stage in the process of urbanization has been quite fashionable in the policy arena in recent years, with the aim of drawing a distinction from the terms digital city or intelligent city. Its main focus is still on the role of ICT infrastructure, but much research has also been carried out on the role of human capital education, social and relational capital and environmental interest as important drivers of urban growth. The European Union, in particular, has devoted constant efforts to devising a strategy for achieving urban growth in a smart sense for its metropolitan city regions. Other international institutions and think tanks also believe in a wired, ICT-driven form of development. The Intelligent Community Forum produces, for instance, research on the local effects of the worldwide ICT revolution. The OECD and Eurostat Oslo manual stresses instead the role of innovation in ICT sectors and provides a toolkit to identify consistent indicators, thus shaping a sound framework of analysis for researchers on urban innovation. At a meso-regional level, we observe renewed attention for the role of soft communication infrastructure in determining economic performance. The availability and quality of the ICT infrastructure is not the only definition of a smart or intelligent city. Other definitions stress the role of human capital and education and learning in urban development. It has been shown, for example, that the most rapid urban growth rates have been achieved in cities where a high share of educated labor force is available. Innovation is driven by entrepreneurs who innovate in industries and products which require an increasingly more skilled labor force. Because not all cities are equally successful in investing in human capital, an educated labor force the creative class is spatially clustering over time. This tendency for cities to diverge in terms of human capital has attracted the attention of researchers and policymakers. It turns out that some cities, which were in the past better endowed with a skilled labor force, have managed to attract more skilled labor, whereas competing cities fail to do so. Policymakers, and in particular European ones, are most likely to attach a consistent weight to spatial homogeneity. In these circumstances, the progressive clustering of urban human capital is then a major concern. Characteristics. The label smart city is still quite a fuzzy concept and is used in ways that are not always consistent. This section summarizes the characteristics of a smart city that most frequently recur in discussions of the topic. A stage reached in the development of infrastructure, this usage is centered around the utilization of networked infrastructure to improve economic and political efficiency and enable social, cultural and urban development, where the term infrastructure indicates business services, housing, leisure and lifestyle services, and ICTs, and brings to the forefront the idea of a wired city as the main development model and of connectivity as the source of growth. The critical role of high-tech and creative industries in long-run urban growth is stressed. This factor, along with soft infrastructure, is the core of Richard Florida's research. The basic idea is that creative occupations are growing and firms now orient themselves to attract the creative. While the presence of a creative and skilled workforce does not guarantee urban performance, in a knowledge-intensive and increasingly globalized economy, these factors will determine increasingly the success of cities. A strategy for creating a competitive environment. Here, a Smart City unregistered trademark is taken to be one that takes advantage of the opportunities ICTs offer to increase local prosperity and competitiveness, an approach which implies integrated urban development based on multi-actor, multi-sector, and multi-level perspectives. This leads to an underlying emphasis on business-led urban development, creating business-friendly cities with the aim of attracting new businesses. The data shows that business-oriented cities are indeed among those with a satisfactory socio-economic performance. To this end, cities may design business parks as a Smart City ISA unregistered trademark. Kwachi, Malta, Dubai are all examples. Local intelligence capacity is intrinsically linked to that of the knowledge-based economy where innovation and technology are main drivers of growth and the collective community intelligence, which underlines capacity and networks as main drivers of a community's success. This requires a planning paradigm pertinent for urban regional development and innovation management, similar to the related concept of a intelligent city ISA unregistered trademark. By developing sector-focused, cluster-based or more complex intelligent city strategies, territories can set in motion innovation mechanisms of global dimensions and enhance substantially their innovation systems. An approach to inclusive and sustainable cities. An alternative approach gives profound attention to the role of social and relational capital in urban development. Here, a smart city will be a city whose community has learned to learn, adapt and innovate. This can include a strong focus on the aim to achieve the social inclusion of various urban residents in public services and emphasis on citizen participation in co-design. Sustainability is seen here as a major strategic component of smart cities. The move towards social sustainability can be seen in the integration of e-participation techniques such as online consultation and deliberation over proposed service changes to support the participation of users as citizens in the democratization of decisions taken about future levels of provision. Environmental sustainability is important in a world where resources are scarce, and where cities are increasingly basing their development and wealth on tourism and natural resources. Their exploitation must guarantee the safe and renewable use of natural heritage. This last point is linked to business-led development, because the wise balance of growth-enhancing measures, on the one hand, and the protection of weak links, on the other, is a cornerstone for sustainable urban development. Wireless sensor networks for smart cities. Wireless sensor networks is a specific technology that helps to create smart cities. The aim is to create a distributed network of intelligent sensor nodes which can measure many parameters for a more efficient management of the city. The data is delivered wirelessly and in real time to the citizens or the appropriate authorities. For example, citizens can monitor the pollution concentration in each street of the city, or they can get automatic alarms when the radiation level rises a certain level. It is also possible for the authorities to optimize the irrigation of parks or the lighting of the city. Water leaks can be easily detected or noise maps can be obtained. Rubbish bins can send an alarm when they are close to being full. Vehicle traffic can be monitored in order to modify the city lights in a dynamic way. Traffic can be reduced with systems that detect where the nearest available parking slot is. Motorists get timely information so they can locate a free parking slot quickly, saving time and fuel. This information can reduce traffic jams and pollution, improve the quality of life. It has also been recently asserted that, due to the revenue-generating nature of parking, smart parking systems could be the ideal foundation for building municipal wireless networks. These sensing networks could later be extended to include other types of sensing, as California-based company Streetline announced it would offer in early 2014, adding road surface temperature and noise sensing capabilities to its smart parking portfolio. Combined sewer overflow events can be mitigated by using distributed rainwater harvesting infrastructure to reduce peak flows and maximize wet weather capture. This enables wastewater treatment facilities to treat stormwater runoff rather than it being flushed to the receiving water body. Online collaborative sensor data management platforms. Online collaborative sensor data management platforms are online database services that allow sensor owners to register and connect their devices to feed data into an online database for storage, and also allow developers to connect to the database and build their own applications based on that data. Examples include Zively and the Wiki Sensing platform. Such platforms simplify online collaboration between users over diverse data sets ranging from energy and environment data to collected from transport services. Other services include allowing developers to embed real-time graphs and widgets in websites. Analyze and process historical data pulled from the data feeds. Send real-time alerts from any data stream to control scripts, devices and environments. The architecture of the Wiki Sensing system describes the key components of such systems to include APIs and interfaces for online collaborators, a middleware containing the business logic needed for the sensor data management and processing, and a storage model suitable for the efficient storage and retrieval of large volumes of data. Criticism. The main arguments against the superficial use of this concept in the policy arena are: a bias in strategic interest may lead to ignoring alternative avenues of promising urban development. The focus of the concept of smart city may lead to an underestimation of the possible negative effects of the development of the new technological and networked infrastructures needed for a city to be smart. The idea of neoliberal urban spaces has been criticized for the potential risks associated with putting an excessive weight on economic values as the sole driver of urban development. Among these possible development patterns, policymakers would better consider those that depend not only on a business-led model. As a globalized business model is based on capital mobility, following a business-oriented model may result in a losing long-term strategy. The spatial fix inevitably means that mobile capital can often write its own deals to come to town, only to move on when it receives a better deal elsewhere. This is no less true for the smart city than it was for the industrial, or manufacturing city. Examples of use. The term smart city has been used in a variety of instances and applications, including the following examples. Used by cities: Smart City Vienna, Aarhus Smart City, Amsterdam Smart City, Cairo Smart Village, Dubai Smart City, Dubai Internet City, City of Edinburgh Council for their Vision and Action Plan for e-government implementation and modernization. City of Eindhoven manages a living lab for creating and testing valuable applications in the famous bar district Stratumsend and is preparing a smart lighting platform, together with industry, research institutes, and the people living in Eindhoven. Kwachai Smart City Business Park, Lyon Smart City, Smart City Malaga, Malta Smart City Business Park, Smart Santander, Songdo International Business District. Southampton City Council use it to describe their use of smart cards as part of integrated service provision. Yokohama Smart City, Verona Smart City. See also, Smart Cities in India, Cluster Development, the Creative City, Digital City, Intelligent City, Knowledge Economy, Knowledge Spillover, Mesh Cities, Spatial Intelligence of Cities, Sustainable urban infrastructure, triple helix, ubiquitous city, references.